Hello, this is a case study for calculating real rate of growth. Uh, Mr. Wright bought a house at the price of 107,000 in 1988, then sold at 230,000 in 2018. And Mr. Wright did not make any significant remodification on the house. Let's analyze Mr. Wright's deal. Actually, we need to calculate the real rate of growth of house value. First, we need to use the information we have in this piece. The year is 1988 and 2018. The price of the house is 107,000 and 230,000. We have this information. We can actually calculate the rate of growth over 30 years. Minus divided by 30 years. So from 1988 to 2018, over the 30 years period, the value of the house grew by 114.95%. But in real life, this growth rate is not very useful because mostly investment or GDP or everything we use annual rate of growth. That means we need to get an annualized rate of growth. How to do it? How to do it? The price for buying the house add as the principal. We can use the financial formula. The price of buying the house placed as the principal, and the price of selling is the accumulate amount, and we assume the interest is compound annually. So M here equals to what? So we get the simplified formula here. From this formula, we just need to do some algebra, and we can get the annualized rate of growth as this. So we can calculate the R. Use this formula. Actually, we already calculated. Let's create equal title equal and parenthesis A. A is the accumulated amount or the ending amount. divide by the beginning amount, and then close the parenthesis, and then raise to the 1 over t power. Here is t is 30 years. 30, and then minus 1. Return. Oh, we got the 2.584%. This is the annual or annualized rate of growth, but this rate is nominal. That means it doesn't take inflation into account. So how to calculate the real growth rate? That means how to adjust for inflation. We use CPI. So just do some research on the website, and I actually download a CPI historical CPI table from my website. And so we just need to figure out 2 years CPI. CPI in the year of 1980 is 118.3. CPI in the year of 2018 is 251. What these two numbers mean? These two numbers means 118.3 dollars in 1988 and 251.107 in 2018 have the same purchasing power. What does the same purchasing power mean? It means they can buy the same amount of stuff. In economics, there is a market basket to measure the same amount of stuff. This stuff is the consumer, the regular stuff consumer regularly buy. Housing, food, and energy, etc. We are not going to dive into it. Now we just know what the CPI mean. These two numbers can buy the same stuff. CPI, Consumer Price Index. We have CPI. We can use this formula to calculate the value, the constant dollar value in 1988. That means we need to convert the price here into 1988 dollar. So this is the same price in 1988 is the same. We just click this cell and then this one, use the formula. The price in 2018 and times 2018 CPI divided by 1980's CPI. It doesn't matter, but better for better understanding, use a parenthesis. Then we return. Oh, I think I made a mistake. It should be convert into the price, the value in 1988. The numerator should be the CPI here, and denominator should be this one. Okay, return. Okay, we got the value in 1988. This is constant dollar. The price here usually refers as current dollar. That means the price are expressed as that year's currency. This is constant dollar. Although the price converts to a base year's dollar. The base year here is 1988, and so we can calculate the real rate of growth. We can just copy this formula to here. Oh, we can get the real rate of growth is only 0.042%. That almost no growth. Actually, we can convert the price in 2018's dollar. So the price in 2018 is the same. So we only need to convert the price in 1988 into value in 2018. So price times price parenthesis. Now remember, 2018's CPI divided by 1988 CPI, close the parenthesis, return. Okay, we can, when we have the constant dollar value, we can calculate the real rate of growth. Actually, we can just dry over. Yeah, the same. If you want to convert the price into the year you want, for example, we can convert the price into any year's value, 2000. What you need to do is you need to figure out, do the research on the internet, get the 2000's CPI, and use this formula to convert the price into 2000's value and calculate the real rate of growth. You will get the same number here. The other way to calculate the real rate of growth is use the Fisher's effect formula. Use this formula. Here we already have the nominal rate. How to calculate the inflation rate? Actually, it's the same. The price the CPI grows from 118.3 to 251.107. So over the 30 years annually, the rate of inflation is you use the same formula here. So I actually don't need to tie it. Use the same formula here. The ending CPI, the beginning CPI, use the formula here. We can just drive over here. Oh, this is the annual inflation rate. As this is our A. So we just substitute this number RA into the Fisher's effect formula. R minus A, close the parenthesis, over 1 plus A, enter. Oh, this the same. Well, we got the same real rate of growth from two methods. Anyway, they should be the same. Otherwise, we need to check over what mistakes we made. In real life, actually, we just need to give a approximation of the real rate of growth. So we usually just use the nominal rate minus the inflation rate. This one minus this one, approximately we got we got 0.043, and that is very, very close to the real one. That's all.